Hello and welcome back, everybody. In this portion of this module of developmental psychology, as was mentioned before, we're going to be turning our attention back to where developmental psychology really started to take shape. In particular, we're going to be covering a lot of work by the famous theorist named Jean Piaget. We will branch out into some other things as we progress, but just so you have a better sense of where we're going to be going, I figured it was worth mentioning the idea of Piaget before we get started. In terms of why we celebrate Piaget, it's probably first important to understand not only his contributions, but where his ideas came from. Jean Piaget was around during a very interesting period of the early 1900s where things like intelligence tests and other measures of cognitive ability had started to become standardized. And in particular, Piaget was an individual in the early 1900s that was tasked to try to revise some of the original tests developed by somebody in intelligence named Alfred Binet. He was trying to essentially come up with more elaborate and more complex ways of measuring intelligence in young kids. But as Piaget started to do this, he ran into kind of an unexpected problem. In particular, he kept finding that kids were getting specific problems that he had designed incorrect, but they were getting it incorrect in a very consistent way, in ways that almost suggested that these children were not understanding the questions or just perceiving the questions in a completely different way. And this was surprising to Piaget, it was surprising to theorists and researchers at the time, because at that moment in time when Piaget was working on this, most psychologists were operating under the premise that our intelligence was really just a byproduct of how much we'd acquired, how much information we'd learned. The belief was that kids and adolescents and adults all thought about the world roughly the same way. It was just kids had significantly less information in their heads than adults. And as we aged or became more intelligent, more information would simply just be input into the brain. But this didn't seem to be the case when Piaget started testing these children. So he decided to dedicate a large portion of his career to trying to figure out what was really the source of these abnormal response patterns. A large portion of his tests were actually done on three probably unwilling participants. His three children that you see pictured here on this slide, Laurent, Lucien, and Jacqueline. He would put them through different rigors, not every day necessarily, but multiple times as they grew up to see if they consistently got specific questions wrong or right and how they got those things wrong. So he could form his framework for what later became his theory of cognitive development. And from his work with his children and additional work with a whole slew of other children that he was able to recruit for his labs, Piaget came to some pretty groundbreaking conclusions. He came to recognize that when we're looking at kids or adolescents or even young adults, that there's not just a quantitative difference in what they see the world as or kind of how they process the world. Instead, it was more a qualitative difference. In essence, they saw things in very different ways and processed things in ways that other people didn't process. And to explain how this process or this change might occur as we age, Piaget started looking at this concept of what we nowadays call adaptation, of adjusting to the problems and adjusting to the shortcomings that we encounter along the way. Now, how do we adapt? How do we actually alter our thinking when we transition from infancy into childhood and childhood into adolescence and beyond? Now, this is also something that Piaget started to tackle as he formed this theory of cognitive development. At the heart of Piaget's theory was this idea of something that he called a schema, a concept or framework that we use to understand the world around us. Schemas can be fairly simple in terms of, what makes an orange, or how black is different than gray. It can be simple like that, or it can start to get complex, like what is our identity, or how does gravity work? And Piaget argued that when we're born, we inherently start to try to form these schemas, these tools that we can use to better predict and interact with the world. But he said oftentimes when kids do this, their early schemas are extremely imperfect. There's lots of flaws to them or things that they don't necessarily catch. If a child does form a schema that seems to match the world around them, they might temporarily be in a state of mind that he called equilibrium. But when those imperfect schemas encounter problems, things that they can't particularly explain in their current form, this causes the child to experience something that he calls disequilibrium. And he said that this disequilibrium is really at the heart of that adaptation process that we talked about earlier. Because when children encounter disequilibrium, the discomfort that's caused by it pushes them to do one of two different things. Either assimilation, which is just kind of finding a way to reinterpret that experience or remember that information so we don't have to really alter our schema at all, or accommodation, where we decide to change, alter our schema to correct for that disequilibrium, and in doing so, probably increase the chances of not experiencing it again. Of course, accommodation is a lot of work, and oftentimes we don't quite know how to tweak our schemas when we start to encounter conflicts right off the bat. So oftentimes this growth process, this change of schemas takes time, takes lots of moments where we experience disequilibrium. In fact, we probably assimilate much more often than we accommodate. But if we do accommodate correctly and we start to form a good schema through multiple exposures to conflicting information, well, then we can get ourselves back to that state of mind called equilibrium, which he called the process of equilibration, kind of finding a way back to that happy medium. If you want an example of how this might work, we could pretend that we're, say, a 3 or 4 year old child. And let's say we haven't been exposed to a lot of things in our young childhood, but at some point we have a play date set up with a family member or a friend, and we go over to that family member or friend's house. And at this house comes out of the corner this weird looking thing that's bounding after us and licking us and trying to tackle us. And we ask our friend or family member, what is that thing? What is this thing that's licking me or jumping on me? And the friend says, well, that's doggy. Well, at this point, Piaget would argue that you start to try to form a schema for what makes a doggy a doggy. And I'm guessing many of you, when you think about this idea, can start to postulate some of the things, rules that you use to what makes a doggy a doggy. You might talk about having 4 legs, having fur, having kind of a snout or a face that protrudes, having lots of energy, maybe licking you is what makes a doggy a doggy. And if you say, do form that schema and go to another friend's house or another family member's house and this thing bounds out and you call it doggy and they say yes, you would be in that state of mind that Piaget called equilibrium. You would have set up a schema that seems to be matching with your environment. Let's say instead of this thing bounding out the next time you encounter some friend play date, this thing bounds out. Well, you might, as would be expected, call this thing a doggy. And if your family member or friend is intuitive and kind of recognizes that's not right, they might say something like, no, that's kitty, or that's cat. And at that moment, Piaget argued you'd be in that state of mind called disequilibrium. You'd be struggling to try to figure out where your schema went awry. Now, odds are pretty good. You'd probably just assimilate that first exposure. Right? You'd come to the conclusion that maybe they thought that you were trying to figure out the name of this doggy and they call this doggy Kitty. Or maybe when they said Kitty, they were talking about the face, not the body, or something odd like that. Or maybe you just kind of forget that experience altogether. But if you encountered enough conflict, enough times where people were correcting you, Piaget would argue that you'd start to go through this process of accommodation. You'd start to try to understand what truly made a doggy, and in this particular case, what differentiated that doggy from this new thing that is apparently called a kitty. And through that learning process, your schemas would evolve and your thinking would evolve, and you would start to see the world in a slightly different way. Now, this idea of equilibration and the idea of forming schemas and trying to kind of understand the world around us is really at the heart of Piaget's cognitive theory. What made it even more interesting and started to really encourage people to celebrate it as a means of trying to understand a whole bunch about individuals is the fact that he took these basic ideas and premises and then started to apply it to how it might map out on most individuals. In Piaget's work, when looking at kids, he noticed that not only did kids go through this unfolding process, but when looking at major schemas, they seem to go through this process in a very predictable sequential order. Right? There were certain concepts, certain problems that all infants dealt with, and then in early childhood, a different set of problems arose. And this changing and altering and formation of schemas really was kind of persistent and also consistent from child to child. And after that early childhood years struggles were up, they transitioned to childhood years where new struggles, new problems would pop up. Within each of these advancements, there was a collection of things that had to be mastered before the child could really progress to the next stage. And at the heart of it, again, was this attempt to restore equilibrium, to come up with schemas that were really explaining the challenges in the world that we were facing at different points in our life. Not only did he talk about that sequential order, but Piaget then did actually map out exactly when things should roughly happen. Most of Piaget's early work focused on four discrete stages of cognitive development that he said all of us underwent before we got into adulthood and started to think like, well, pretty much everybody else. The first stage he talked about was something called the sensory motor stage, the next called the pre-operational stage, the third called the concrete operational stage, and the last called the formal operational stage. With the sensory motor stage just lasting 2 years, and each additional one lasting somewhere between 4 and 5 years. And this idea of us progressing through these stages and having names for them then led Piaget to differentiating exactly what we were trying to master within each stage. And the sensory motor stage, that very first stage that Piaget talked about, his argument was that most of our cognitive attention was really dedicated to figuring out what's in the name of this stage, our senses and our motor system. His argument was that we dedicate all of our energy, all of our time, pretty much to just being able to move when we want to move and perceive what we want to perceive. But he said, in conjunction with this focus, there were some other really big ideas that we were starting to try to grapple with by about the time we reached a year of age. One of the big challenges he said we struggled with cognitively at this age was to understand this concept of something called object permanence, that things continue to exist even if we can't necessarily see or feel them. The classic Piaget test on object permanence is actually depicted here in the pictures on the right, where a child might be staring at a toy or a stuffed animal, and that animal is then covered by a piece of paper or a blanket. And Piaget argued that if the child didn't understand object permanence, they would come to the conclusion that that covered object, that covered toy, no longer existed. But if they understood it, they could recognize that the toy continued to exist even if blocked. Now, Piaget concluded that this was something that formed by about a year of age. Subsequent researchers actually suggested that maybe it happens a little bit earlier, and there's maybe other elements to object permanence that we could explore to verify that children understand that things continue to exist and retain their properties even if we can't see them. In fact, I pulled up a video that you should see a link for on the class website to highlight some of that work that was done in the late 90s, early 2000s, trying to grapple with this idea of object permanence from a slightly different perspective. I encourage you to watch that at your convenience so you can better understand not only what object permanence is about, but how we've evolved since Piaget introduced this idea almost a century ago at this point. Another thing that he closely linked to the sensory motor stage was this idea of something called a sense of self. He very famously developed this thing called the Rouge test, where he would put a red dot on the nose of children and then place a mirror in front of them, trying to determine if they could recognize the face in the mirror and that red dot on that face was indeed their own. He surmised that if a child reached for the mirror, they would not necessarily be clear on what they looked like, and they would not have developed what he called a sense of self. But if they reached for their nose, well, that would suggest that maybe they had some intuitive sense of who they were. They could recognize their reflection, and they also recognized that they were a part of the world around them, not just this thing that was taking in all of the different components of the world that was interacting with it. Now, this sense of self is not necessarily a perfected thing by the time we reach two. But Piaget argued that we mostly have a decent sense of self by the time we're one. We're working on it as we're developing other sensory skills and other motor skills. So by the time we reach two, we get about as good as we need to be to progress to the next stage of development. And that next stage of development was again what Piaget called the pre-operational stage, which he said started at about 2 and lasted to about 7 years of age. When kids got to this stage, they started to tackle a new set of problems, a lot of them dealing with reality and kind of understanding different perspectives and different scenarios that we might potentially encounter. One challenge, he said, many kids first face when getting into this pre-operational stage is the ability to engage in what's called pretend play, and in doing so, also recognize different perspectives and different things that other people might experience. The ability to overcome this thing that we nowadays call egocentrism. You can see actually in one of the photographs on the right an image of two girls having a tea party. And I love this image because it really does highlight how challenging the world might seem if we don't understand pretend play. You can see the girl on the left, who's probably 2.5, maybe 3 years of age, having a tea party with her sister, and she's pouring tea. She's holding that piece of cake very daintily, and it looks like she's having a good time with this pretend tea party. But if you look at her sister, who's probably a year and a half, maybe 2 years of age, you see a very different set of expressions. You can see frustration on her face. You can see a vice grip that she's put on that cupcake that she has in her hand. If you look closely at the teacup that she was obviously assigned, you can see it's all mangled and crumpled up. And my guess is that she's become frustrated several times because she doesn't understand why her sister's talking about how good the cakes taste and how these cups are filled with tea when obviously there doesn't seem to be any tea being poured at all. It's because she's struggling with this idea of pretend play, and it makes this a very different situation from her older sister's situation that's being experienced at the exact same time. And this is partially a byproduct of her not understanding hypotheticals, but it's also a byproduct of not being able to understand other people's perspectives. And this very closely relates to that ability to overcome this thing that we call egocentrism, where we assume that everybody knows what we know and sees what we see, and there's no other perspectives that could possibly exist. Classic test for egocentrism is actually one that you see depicted above, this thing called the model of mountains task, where kids are seated in a specific position, usually it's in seat A, and asked what people might see if they sit to the side, say in seat B or D, in the images above. And what most research has suggested is when a 2-year-old's asked this, doesn't matter which seat somebody hypothetically is sitting in, they're going to assume that the other person sitting in a different seat will see the same thing they're seeing. They'll select photo 1 and say this is what that person will see. Over time, as they advance in the pre-operational stage, they start to recognize that that particular image can't be what other people see. They might struggle with the ability to take the perspective of others. So they might start guessing, but eventually they'll realize that they need to kind of reflect on what others might see, the orientation of things, and in doing so, they can start to get better and better at this task. They can also start to understand that others do sometimes remember and see things differently than they do. But it takes time. If you've ever been around a 3-year-old, you've probably encountered this egocentric thinking. Like if you've been around a 4 or 5-year-old, you've probably encountered some version of this egocentric thinking, where if you ask them about their day or have a conversation with them about some friend, they really struggle to understand that you don't know everything they know and you didn't experience everything that they experienced. It's a big challenge for these kids, but this is what they're grappling with during the pre-operational stage. They're also struggling with something called animism, where they try to learn how to differentiate between what's called an animate object, something that can move, and an inanimate object, something that shouldn't move. Until they get that, being able to differentiate between, say, that snowman in the picture on the right and somebody that's maybe taking that picture is a real challenge for kids. Not that they see those things as equivalent to each other, but now, for this boy that you see in the picture, he might indeed be worried that that snowman could get up and grab him, or that if he falls on the sidewalk, that it was because the sidewalk grabbed his shoe, not he tripped on something that couldn't possibly move. This all kind of deals with the ability to have flexible thinking, and it also relates to the biggest challenge that kids often struggle with during the pre-operational stage, and it's the ability to process something that we call symbolism. Now, symbolism actually bleeds into a lot of different topics, but the classic example of symbolism and the thing that kids struggle most with during this stage when it comes to symbolism is learning words, learning vocabulary, and maybe even learning letters and how to actually read things. And Piaget argued that kids do struggle with this, but they quickly learn how to develop tools to kind of enhance their chances of learning as many symbols as possible during this stage. One classic thing that developmental psychologists often cite is a word that you might have encountered a lot of times if you've ever been around a 3, 4, 5-year-old. It's that wonderful word of why. Now you might wonder why a 3 or 4-year-old is constantly asking you why when you explain something or when you tell them things. You might think they're either being petulant or just maybe not understanding what's going on. But Piaget and other developmental psychologists have argued that what they're doing is really just using a trick. They know if they say the word why, you'll probably keep talking. And you'll maybe even repeat yourself a couple times, which can help them understand the words you're using even better. But this is really just one component to symbolism. It's definitely a big one. It's by far the most focused on one for most kids. But there are other symbols that kids do start to process. Things like scale models, for example, is something that kids really do start to pick up on. And so you can understand scale models a little bit better. I thought I'd provide you with a link to another video. So please be mindful of the timestamp linked to it. But if you can, at your convenience, when you can, check out that video and you can understand a new element to symbolism that maybe wasn't the primary focus of Piaget's, but one that we've looked at since Piaget's work in the early 1900s. Another big challenge that lots of kids face during the end of the pre-operational stage is the ability to understand something called conservation. Now, if we are going back to the time of Piaget, conservation was believed to actually be the thing that either was the start of the next stage of cognitive development or really culminated the end of the pre-operational stage of cognitive development. Nowadays, researchers tend to believe that the ability to understand conservation probably happens a little bit earlier. It's just we have to word things correctly. The classic test for a child's ability to understand conservation is actually depicted in this image that you see in front of you. A scientist or a researcher will put up two beakers of water in front of a child and ask if one has more than the other or if they're the same. And if they've done their due diligence, those two beakers should have the exact same amount of fluid in them, so the child will say they're the same. Then that scientist or researcher will flip one of the beakers over, with the smaller end now being at the bottom of one of them, and ask that child again whether or not one has more or they're the same. And if we understand the concept of conservation, we can recognize pretty quickly that even though the heights of those are different, because no water's been taken out or added, they still remain just as full as each other. But for a child who doesn't understand conservation, they'll indicate usually, like you see in the picture, the taller one is the one that has more water. This is all about a lack of understanding of conservation. There's other examples of this as well. You can take a ball of Play-Doh, put it next to a kid and another ball that's very similar, ask if they're the same or one of them has more, and they'll usually indicate that the two balls are about the same. And then if you smash one down, suddenly that smashed one has way less Play-Doh in it than the super big one. If you expand a pizza, separate the pieces out, or cut it into more pieces, a child will instantly believe that that pizza somehow just obtained more matter. It got bigger and had more in it due to your actions. It takes a while for a kid to understand conservation, but, and this is pretty important, most kids seem to understand, if we word things correctly, conservation much earlier than Piaget had originally thought. Most children start to work on it and maybe even master it by the time we reach around 4 to 5 years of age. Almost all kids understand conservation pretty darn well by the time they're 6, maybe 7. But this is obviously much earlier than that 7-year cutoff that Piaget talked about originally in his research. And how does this happen? Well, some people believe that this happens probably due to the early development of something that's really a key component to the next stage of cognitive development, the stage that we call the concrete operational stage. Piaget thought that once we get to the concrete operational stage, we really focus on mastering this thing called metacognition, the ability to kind of think about our thinking and have an internal dialogue that we can use to understand the world around us. For the task of conservation, or for the challenge of conservation, Piaget and others have argued that metacognition plays a key role in the ability to really decipher that there is conservation the things that we encounter. He, in fact, said when he was testing kids that many kids at around 5, 6 years of age seemed to talk with him about what they were encountering when they realized that they weren't understanding the questions correctly or weren't really processing how conservation worked correctly. And then he said they'd eventually transition from talking to him to talking to themselves to then maybe whispering to themselves and then having this insight that they could have a conversation on their own without even needing to really talk. That ability to have that inner dialogue was considered by Piaget and many other developmental psychologists as just the first kind of indications that metacognitive skills were starting to develop. We could maybe tap into the emotions we were feeling, the thoughts we were having, some of the experiences we were maybe encountering at that time or in the past to really understand stuff at a greater depth. And what the development of metacognitive skills allowed us to do, Piaget argued, was engage in much more critical thinking than we'd ever been able to engage in before. We could do and undo things and remember things in ways that we never were capable of before. A great example of this is actually something that we can replicate here in this lecture. Let's say I asked you to count the number of pennies that were pictured on the slide here. I'm guessing that nobody would struggle with this. You can count yourself, but I promise you all come to the same conclusion. This is not a trick question. But let's now say that I took some of those pennies away. I asked you to count how many were there now. This all just involves basic counting. Metacognition isn't playing a role yet. Let's say we took one last step, and I asked you to close your eyes, and I was going to put all the pennies I took away back on the screen. If I asked you how many pennies were going to be on the screen when you opened your eyes, I'm guessing most of you could easily indicate exactly how many should be there. This isn't challenging for you. You can do and undo these things. You can access your memory in ways that you kind of take for granted. But for a child just developing those metacognitive skills, For them, when they open their eyes, they're going to have to count those pennies all over again to be able to determine how many are there, how many are now in that image. This ability to do that stuff, which we take for granted, is something that most researchers argue is happening during the concrete operational stage. It's also happening at the same time as we develop skills to kind of recognize relationships between things. We can start to do basic analogies like the one you see here. Run is to walk, as fast as to slow, halt, or run. I'm guessing most of you know the answer to that because, well, most of you are past this concrete operational stage. Most of us probably don't even think twice about this, but Piaget and others have argued that this isn't always the case. It took time for you to develop those skills. But once you did, once those metacognitive skills had really gotten strong enough for you to process a lot of stuff, then you turned your attention to the last set of problems that were a part of the last stage of development, the stage being called the formal operational stage. Formal operational stage is really not that different from the concrete operational stage. It's just in this one, our thinking gets even more complex. We start to think about hypotheticals, ideal situations. We start to tackle much more complex logic problems and have the ability to engage in what's sometimes called deductive reasoning, where we say stuff like, well, if I'm going to do this, then this could happen. Or if I really want to get the most out of this is what I should do. We're not great at this when we start in the formal operational stage, but we start to work on this for around 4 or 5 years, depending upon when we get into this type of thinking. And by the end, we theoretically can engage in much more critical thinking than we could before. But while we're going through this process, Piaget and others have argued that there are some side effects to it. There was a theorist named David Elkin who coined the term adolescent egocentrism a couple decades ago to really highlight one of the side effects that could happen during this formal operational stage. He said for many kids, we essentially don't lose egocentric thinking, but we kind of become egocentric in a slightly different way. We know that others see things that we don't see and know things that we don't know, but we start to believe that people think about us and watch us and care a lot more about us, a lot more than they probably actually do. And this idea of adolescence egocentrism, Elkind said, allows for other kind of fictitious thinking to develop. One of the things he said starts to pop up in many kids' minds when they reach 11, 12 years of age is this thing called an imaginary audience, where they start to see others as paying a massive amount of attention to them, even if that's not actually the case. And they also see themselves as having some type of an arc to a story that's being tied to them, which can have the side effect of them believing that that story has to play out. So there are no maybe consequences for some of the less well thought decisions that they might be making at the time. Elkind and Piaget and others argue that most of these follies and issues with abstract reasoning gets resolved by the time we reach 15. Other researchers have suggested that maybe 15 isn't some magical number. Maybe many people struggle with adolescent egocentrism long after they're in adolescence, maybe even until middle or late adulthood. And some have argued that maybe we're never really great with abstract reasoning. Maybe we can't do logic problems like we think we should be able to. But regardless of when the cutoff is, this idea of us having to struggle with these things was really interesting, and it was something that Piaget introduced to us again almost a century ago. You're wondering about some of the challenges, some of the abstract reasoning questions that people might encounter. I thought I'd give you some just to verify that you're thinking beyond the age of 13 or 14. So let's say I gave you this question. If Rita does her homework in the class, the teacher will give her an A, and then I told you Rita did her homework. What would the inevitable outcome be? I guess as most of you know exactly what would happen for Rita based on this information. For those of you that can't, well, maybe we're not quite past this formal operational stage, regardless of how old you are. Let's give you another one that's a little bit more challenging. If I say John and his sister Sally both want to go home from school, but they only have one bike, and this means that one of them will get to ride the bike home while the other will have to walk, and I tell you John rode his bike home, most of you, if you're still following along, can probably quickly conclude not only what happened to Sally, but also what happened to the relationship between John and Sally after this event had occurred. And your ability to do that suggests, again, that you've worked your way through this formal operational stage. But when kids get to this point, this is a challenge. This is a really tough thing for them to be able to process. Let's look at the kind of culmination of this stage. Let's say I told you that Tommy can run faster than Jenny and Jenny can run faster than Mark. And then I ask you who's faster, Tommy or Mark. I'm guessing if you take just a second, pause, and look at it, you know who's faster in this one. But for some kids, this would seem like an impossible question. It's not until you've really formed that inner dialogue and been able to work on this abstract thinking that you can really tackle problems like this. And it allows you also to be a little bit better at planning things. We might not always follow through, but most of us, by the time we reach 16, 17, 18, have the ability to recognize that there are consequences to our actions, short-term ones and long-term ones, and our ability to recognize those consequences tends to lead to at least slightly better decision making in our lives. I'm not indicating that all adults think really well and make the best decisions, but most of us, when we compare our adult selves to our adolescent selves, early adolescent selves, can probably identify that things settled down a little bit once we got past that formal operational stage. And that formal stage, for at least a long period of time, really marked the end of Piaget's work. He did later explore different types of thinking that could potentially happen in adulthood, but the basic premise that Piaget put forth in the early 1900s is what we really want to focus on today, because it was the groundwork for lots of other subsequent developmental work. There were, of course, though, some nuances to it that I want to reiterate. He focused on this notion that children were indeed different from adults, and that we went through these progressive experiences, these changes, in the attempt to adapt to the world around us so we could progress from childhood into adulthood. Now, we tend to celebrate Piaget as a groundbreaking figure in research and a groundbreaking figure in understanding this process of development. But I also want to, in a class like this, acknowledge that there have been some individuals that have rejected a lot of the things that Piaget assumed in his early theory of cognitive development. One of the major issues that people often have with Piaget's theories is that his timing seemed to be off. He tended to sometimes underestimate when young kids could process things like conservation and object permanence, but also overestimate when we mastered later things like the ability to think abstractly and to kind of overcome that egocentric thinking that we were talking about earlier. And how could we explain these problems? Well, might have been partially a bias issue with Piaget, but others have argued that maybe it was just because Piaget didn't have any tools at his disposal when he was coming up with this theory. He had to invent the tests out of thin air. There was no manual for how to test for object permanence or conservation or anything like that when he started to explore these components to the mind. Some have argued that, in fact, Piaget himself might have course corrected and altered some of his numbers if he was given the time to kind of critique his own work and really look at whether or not the timing truly worked. Another problem, though, another complaint that people have with Piaget's is one that can't easily be solved with his theory of cognitive development and some minor revisions. And it's the fact that there has been shown to be a large amount of variation from not only person to person as to when different problems are conquered, but a big difference from culture to culture as to when most people in those different cultures seem to be able to grasp specific cognitive problems. And this issue of inconsistencies, big differences across groups, has actually led a lot of people to look at not Piaget, but a not even a coworker of Piaget, but a person that was looking at cognitive development about the same time as Piaget, another gentleman named Lev Vygotsky. Vygotsky was a Russian researcher about the same time as Piaget who came to the same conclusion as Piaget that kids, when he was testing them and looking at their cognitive abilities, seemed to be seeing the world in a very different place. Instead of trying to come up with a model of different stages of development and study a whole slew of terms like Piaget did, Vygotsky focused his attention on the process of growth, how one might actually transition from one stage to another. At the heart of this theory that Vygotsky introduced was this notion that when we look at change, it's a gradual thing and something that's really a byproduct of the individual, not just some nature thing that had to naturally unfold. In his work, he talked about these zones that he called zones of proximal development, these moments in life where children might be able to conquer a cognitive challenge, a task that was happening in somewhat the same sequential order as Piaget had talked about, but could be tackled earlier if they were given the right guidance, if they were exposed to the right types of challenges that could allow them to process something a little bit more quickly. Now, this technique that would allow these kids to progress was eventually called scaffolding, teaching kids at a level just slightly above their current level of understanding so they could be pushed, coaxed into understanding something faster. Vygotsky's theory suggested that if we did this correctly, we could speed a child through a lot of different challenges. Or if there were enough things that related to a problem, a child could easily conquer a challenge before anticipated because of that social environment, because of the interactions that that child got. He wasn't suggesting that you could have a 3-year-old doing calculus, but he was suggesting that through the proper interactions, you could definitely get a child through the pre-operational stage long before they were 7. And you could get a child to kind of work on abstract thinking in a way that allowed them to understand the world much better long before they were 15 years of age. And you could maybe help somebody still struggling with this by helping them with scaffolding, even if they'd passed the age where you would anticipate them to struggle with specific problems. Vygotsky's theory wasn't necessarily intended to be a counter to Piaget's. It was more just something that explained a different components to how cognitive growth occurs, which leads me to a really interesting point. And that's that when people look historically back on Piaget and Vygotsky, one of the questions that people often ask is, well, which one of these theorists is right? And it's not what I want you to get from this. I'm really not sure about whether or not Piaget's timing and his theories can apply to everybody. We're also not sure about whether or not the teaching methods introduced by Vygotsky are 100% accurate. We're also not 100% sure about lots of other theories that started to come about after Piaget and Vygotsky took the stage, like Lawrence Kohlberg and Erik Erikson, other individuals you might read about as you progress. What I want you to understand from these early individuals and their ideas isn't whether or not they're right or wrong, or their timing was perfect or not, but how their ideas, their theories, their attempts had a huge lasting influence on the formation of developmental psychology in decades to come. And this idea of studying changes, things that alter us, looking for things that we can do to impact the alterations of an individual or the growth of an individual, stemmed from people like Piaget and Vygotsky. And these ideas, these notions that they developed are still with us today in a lot of the research that we run. And if you can understand that, and reflecting back on what we covered in the last class, should be a lot easier, and it should give you a much more complete view of what developmental psychology was like and is like today, which means pretty much done for this module. So hopefully you've had a chance to go over the readings. I really wish you the best of luck on the written assignment. Make sure you really spend some time on it. It's a fairly complex one. And I'll see many of you soon. Take care.